Hello friends, welcome to the channel DC Math. This is my first video for class 12 of ISC Mathematics. For this video, I am using the book written by Suranjan Saha and Sabita Saha. This is a standard book published by Kalyani Publishers. This book was last revised by the author and the company on October 2016. In this video, I am going to discuss about some basic concepts of relation and mapping and function, etc. I shall discuss those concepts and some problems in a few videos. This is the first video of those videos. Relation. A relation R from a set A to a set B is defined as a subset of A cross B. We also write it as R is equal to the ordered pair A comma B such that A belongs to A and B belongs to the set B. Small a belongs to the set capital A and small b belongs to the set capital B. A relation is a set of ordered pairs if A and B be any two non-empty sets, then a relation R from the set A to the set B is a subset of A cross B. Here the author is saying that in this case an element A from the set A is said to be related to an element B of the set B by the relation R, and we express this by the symbol A is R related to B. We call this that A is R related to B. It is the symbol of relation between two elements A and B, where A is taken from the set capital A and B is taken from the set capital B. Another is an example has been taken. Here A is equal to 2, 3 and B is the set 2, 3, 4. R mean here A cross B. The set A cross B is 2, 2, 2, 3, 2, 4 and 3, 2, 3, 3, 3, 4. In A cross B there are total 6 elements. 2 into 3 is equal to 6 elements. And the relation, some relation R has been defined by 2, 2, 2, 4 and 3, 3. This R is a subset of the set A cross B. Therefore, R is a relation from the set A to the set B. Another example has been taken. A is equal to 3, 4, 5, B is equal to 4, 5, 6, and the relation has been defined by is a divisor of. Therefore, relation R is 3, 6. 3, 6 belongs to the relation R. Why? Because 3 is a divisor of 6. Again, 4 is related to 4. 4 is related to 4 because 4 is a divisor of 4. And 5 is a divisor of 5. Therefore, 5, 5 also belongs to the relation R. In this way, there are some other examples also, and we can construct by ourselves some examples. Let us learn some types of relations. The first one is empty or void relation. A relation R is a set A is called a relation R in a set A is called empty or void relation if no element of A is related to any element of A. That is, if R is equal to phi is a subset of A cross A. An illustration has been given. They are considering A is equal to 2, 3, 4 and R is equal to A plus B is equal to 8 for A, B is equal to A. Then R is equal to empty set, because if we add any two of 2, 3, 4, no one gives the result of addition, which is 8. No one gives the result 8. Therefore, the relation given by R is an empty relation or a void relation. Another type of relation is universal relation. If R be a relation in a set A and every element of A is related to each element of A, then R is equal to A cross A is an universal relation, because then A cross A is a proper subset of A cross A is a subset of A cross A. This happens. Here one illustration has been given, that is, let us consider A is equal to 1, 3, 4, 5 defined by R is equal to A comma B such that mod of A minus B always greater than is equal to 0. Then we see that the condition A minus B, mod of A minus B is greater than equal to 0 is satisfied by all pair of elements A comma B. That is, we can say that R is a proper subset of, that is, R is a subset of A cross A, therefore R is a universal relation. Why? This is because if we take any two elements from the set A and we subtract them, we see that their modulus is always greater than or equal to 0. Therefore, the relation defined here by the set R is an universal relation. Another type of relation is identity relation. If every element of a set A is related to itself only, then the relation is called identity relation. We denote it by IA. Example of identity relation has been given. One example, IA is equal to 1, 1, 2, 2, 3, 3, where the set A is 1, 2, 3. Here we can easily see that 1 is related to itself, 2 is related to itself, 3 is also related to itself only. Therefore, this is an identity relation. Now we are going to learn some important relations, which are reflexive relation, symmetric relation and transitive relation. After that, we shall learn the term called equivalence relation. Therefore, the next terms are very, very important. A relation R in a set A is called reflexive if A is related to A itself by the relation R for every A belonging to A. Let us consider the set A of all lines which is parallel to the x-axis. Again I am repeating, let us consider a set A which contains all the straight lines which are parallel to the x-axis. Then if we take L1, L2, any two elements L1 and L2 from A for any L1, L2 taken from A, we see that L1 is R related to L2, where we are defining the relation R in this way, that any two elements L1 and L2 taken from the set A are related to each other if L1 is parallel to L2. Always any element taken from A will be, any two elements taken from A will be parallel to each other. Why? Because each straight line taken from the set A is parallel to x-axis. Therefore L1 is parallel to x-axis, also L2 is parallel to x-axis. Therefore L1 and L2 are also parallel to each other. Therefore we can say that any two L1 and L2, for any two L1 and L2 taken from A, L1 is R related to L2. Therefore we can say that R is reflexive. Let us learn another concept called symmetric relation. A relation R on a set A is said to be symmetric if A R related to B means B is R related to A. That is, A R related to B implies B is R related to A. Let us consider this set and this relation on this set A. Previously we have seen that the relation R on the set A is reflexive. Let us see whether this example is symmetric. Here if we take any two L1, L2 from the set A, we see that from this condition that L1 is parallel to L2. Why? Because L1 is parallel to x-axis and L2 is parallel to x-axis according to the structure of the set A. Therefore L1 and L2 both are parallel to each other. This implies that L1 and L2 belongs to R, the relation R. Now if L1 is R related to L2, this also implies that L2 is R related to L1. Why? Because if L1 is R related to L2, that means that L1 is parallel to L2. reversing this, we can say that L2 is also parallel to L1. This is very much obvious. Therefore, L2 is also R related to L1. Therefore, we see that for any L1 comma L2 belonging to the relation R, this implies L2 L1 also belongs to the R, or that is, if L1 and L2 satisfy the relation, then also L2 and L1 also satisfy the relation. Therefore, we can say that R is symmetric. Let us learn about transitive relation. A relation R on a set A is said to be transitive if A are related to B and B are related to C, implies A is R related to C for any three ABC belonging to A. We are again considering this set and this relation. We shall try to see whether this relation on the set is transitive relation or not, is a transitive relation or not. Let us consider any three L1, L2, L3 from the set A. Such that L1 is R related to L2 and L2 is R related to L3. What does this mean? L1 is R related to L2. Therefore, L1 is parallel to L3. L1 is parallel to L2. Where do we get this from? We get this from the basic structure of the set A. Therefore, L1 is parallel to L2. Also, L2 is R related to L3. This implies L2 is parallel to L3. Therefore, combining those two, we get that L1 is parallel to L2 is parallel to L3. That is, L1 is parallel to L3, which means L1 and L3 also belongs, also the pair L1 and L3 also belongs to the relation R. Again, I am repeating, we are considering that L1 and L2 are related to each other and L2 is R related to L3. Therefore, L1 is parallel to L2 and L2 is parallel to L3. Therefore, L1, L2 and L3 are parallel to each other. That is, L1 is parallel to L3, which implies that L1, L3 is also R related. Therefore, we are seeing that for any three arbitrary straight lines L1, L2, and L3 taken from the set A, if L1 is R related to L2 and L2 is R related to L3, then we get L1 is R related to L3, which implies that R is transitive. Let us consider another very important concept. A relation R on a set A is said to be an equivalence relation if it is reflexive, symmetric, and transitive on the set A. If a relation is reflexive, symmetric, and transitive, then we call this relation an equivalence relation. In this example, the relation R defined on the set A, we see that the relation R is reflexive, the relation is also symmetric, the relation is also transitive. Therefore, this example, this is a good example where we can say that R is an equivalence relation on the set A. We can construct many other relations also in this way. No more in this video. In some other video, I shall discuss in details about the relations which are reflexive, which are symmetric, and which are transitive, and also about some relations which are equivalence relations by taking many examples. In those videos, the terms reflexive, symmetric, transitive, and equivalence will be discussed broadly. I hope my first video on ISC Mathematics will help you in your learning. If there is any mistake in this video, please comment positively in the comment section. If you want to know about any other concept of mathematics, let me know in the comment section. No more in this video. Thanks for watching. Please subscribe my channel and like this video. Thanks.